If we can switch the screen, our next speaker is Mustafa Aksoy, who will be speaking about impact of water ice presence in the lunar regolith on surface brightness temperatures from 1 gigahertz.
Hello, good afternoon, everyone. I hope everyone can hear me. I'm an assistant professor at University at Albany, and before starting, I would like to acknowledge my partners in this study, David Hollywood-Baker and Jeff Pittmeyer from NASA Goddard Space Flight Center, and an undergraduate student at UAlbany, Ian Walter. So let's start with the motivation of this study. We all know that measuring the extent of water ice in regolith is critical for future lunar missions. On the other hand, so far, most measurements regarding water ice presence in regolith have focused on either very near surface or lack required special resolution or coverage. And when I mean very near surface, although we guess more ice may be buried in deep regolith. So our objective is to study the impact of water ice presence on 1 to 10 gigahertz surface brightness temperatures to demonstrate the ability of wideband passive microwave radiometry to identify water ice in lunar regolith, possibly in deep regolith down to 10-meter depth. Next slide, please. So we modeled lunar regolith as a planar layered medium where each layer is defined by its thickness, temperature, density, chemical content, and the amount of ice it contains in our studies. We also focused right now on permanently shadowed regions and considered water ice to be spherical particles defined by their radius and distributed uniformly within the regolith. These are just simple assumptions that we did for this initial study. And here on the right-hand side, for example, you can see the regolith density and temperature profiles we assumed in our initial studies. And further assumptions we made, we assumed the thickness of regolith is 10 meters. Each layer is 1 millimeter thick, and the iron oxide and titanium dioxide amount in the regolith is constant and 5%. Next slide, please. And using these physical models, we first calculated the complex permittivity of each regolith layer, and we obtained the nadir surface brightness temperature using this very simple radiation kind of formula you see on the bottom left. And the first observation we made is the significant change, as you can see on the right, in the electromagnetic penetration depth from 1 to 10 gigahertz. At 1 gigahertz, we have almost 10-meter penetration depth, whereas at 10 gigahertz, this is around 1 meter. So from 1 to 10 gigahertz, it's basically possible to probe the entire regolith down to 10-meter depth using wideband microwave radiometers. Next slide, please.
2 minutes.
Okay. And the main goal of research, the impact of ice presence on surface brightness temperature, we studied this by changing the volume fraction of those spherical ice particles in the regolith in our simulations. And here you can see a plot for 1 millimeter radius ice, spherical ice particles. We assume the radius is 1 millimeter. And as you can see from this plot, as we increase the amount of ice in regolith, the brightness temperature spectrum flattens between 1 to 10 gigahertz. The slopes and the flattening rates are different for different ice particle sizes. But overall, we have observed similar characteristics. And this may enable the retrieval of the amount of ice using wideband radiometers in lunar regolith. And next slide, please. So we use this information, this observation, change in the brightness temperature spectrum, and as we change the amount of water ice in regolith, and did a very simple retrieval study to understand the measurement requirements to estimate the amount of subsurface ice in the regolith. So if you can look at the plot on the right-hand side, for example, with a 0.1 Kelvin radiometric resolution, and which can be obtained, for example, with a 12-second measurement across 300 megahertz channels by a typical 1 to 10 gigahertz radiometer, we can obtain a retrieval error smaller than 10% with a 95% confidence level. Of course, this assumes we perfectly characterize the other regolith properties. It's a very well-constrained problem. the reality will be different, but at least the study kind of demonstrates the sensitivity of radiometric measurements to ice presence and potential of 1 to 10 gigahertz microwave radiometry to estimate the amount of ice in Regolith. And next slide, which will be a thank you slide. And thank you very much. If you have any questions, this is my contact information. I will be also hanging around to answer your questions.